Welcome to this section on creating your very first Xamarin.iOS app. This section is incredibly important to understand, so please do not skip it. I'm going to discuss when we create a Xamarin project, all of the files and folders that are created each have a specific function in the iOS ecosystem. I'm going to walk you through exactly what each folder and file is for. And by the end of it, you'll understand not only what they're for, but also in what order they are called when an app is created. I'm going to set you a really simple and quick task to enhance your understanding of the call order that files are called in when an app is fired up. And then finally, I'm going to give you the solution to that task, which isn't too difficult, but expands your debugging knowledge on iOS a little bit. In this lecture, we're going to create our very first Xamarin iOS app. Open up Xamarin Studio. I'm running this on a Mac. You won't be able to do this on a PC, incidentally. Within Xamarin Studio, click New Solution, and you have a bunch of templates you can choose from. We're not going to create a cross-platform app in this series. I'm going to cover that in a completely different series. We're just concentrating on iOS because it's important to know the individual ecosystems before we try to go cross-platform. So click iOS, App. We have some options. Single View App. This is simply a single screen that shows on a device. We have a Master Detail app. And if you look at the screenshot, it's quite similar to, for example, the Gmail app, where you have one pane to select items and another pane that shows those items at the same time. We have a tabbed app, which is the classic iOS pattern, where we have tabs at the bottom that allow us to choose between different screens. We have a page-based app, and typically you would use this when your user first installs an app and you want to present them with a couple of instructions and a few thank you messages, whatever you like. They can swipe through each page before their app actually opens. And finally, we have a web view app, and this seems quite new to Xamarin. I don't recall seeing this before, but we're not going to cover this. So create a single view app and hit Next. Your app needs a name. Let's call this My First App. Your organization identifier is basically your website, but in reverse. So I have gkmicro.com for my consulting. You would put com.gkmicro. And then the bundle identifier that's created below that adds your app name, but lowercases everything and removes spaces by replacing them with a dash. That bundle identifier has to be unique. So if you're planning on publishing on iOS, it's always best to go into your Apple developer account, create the bundle identifier, and check that it is unique. We want devices iPad and iPhone. This is a universal app, so it'll run on both. I don't really foresee any situations where you would only have it on iPhone or iPad, but your case may be different. Then select the minimum iOS version you want to support. These days, I believe iOS 9 is on 77% of devices. That's of February 2016. So you can either choose iOS 9 as the minimum or go all the way back to 8. I'm going to choose 9 for this project. Hit Next. It asks for a project name, a solution name, and where to store it. We'll leave the project and solution as they are, and I'll just store it in projects. Actually, I may put this on my desktop, so I've got easy access to it later. And before you hit Next, you have an option for version control. If you click Use Git for version control, and then you install the GitHub desktop, later on you'll be able to publish this source code direct to GitHub using their desktop application. So I generally leave this checked because although I don't publish a lot of code, when I do, it's much less painful to actually select it now. Right, let's click Create. And all of our project files and structure will be created for us. So we have My First App Master, which is the solution. We have My First App, which is the actual iOS project. Now, when you create a cross-platform application, My First App will be appended with .ios or .droid or with no appendage, depending on the platforms that you're targeting. Right, we've opened up the first file here, the app delegate. The app delegate is the file that iOS uses to communicate to your app. So things like push notifications and general remote control events are usually processed through app delegate. So it's the area that we're going to listen to events for. You wouldn't put most of your app code inside app delegate, so don't do it, because you'll just end up with an enormous file. We'll look at where to put our code much later on. For now, there's only one thing left to do, and that's to run our app. Over in the top left corner, we can click the list of devices down and we can choose, for example, an iPhone 5. We can either have debug or release. If you were going to release it, you would need an Apple developer account. Debug doesn't currently require an account. So let's hit play, and that's going to compile the app, open up the simulator, install it on there, and then run it for us. So just give your iPhone a second to boot up, and Xamarin automatically creates a splash screen for you, and you are presented with a blank app. Come back to Xamarin. Before we click stop in the top left corner, look at the bottom section. We have a couple of windows where we can look at various things like locals, breakpoints, threads. I won't go into these now because we'll cover them as we go through the course. We also have a window called Application Output. And if I click this on, this is all of the messages that have been sent back to Xamarin from our simulator. So if I wanted to send a message to myself from the app, I would write something like console.writeLine, and whenever that's executed, I would get a message somewhere in here to tell me what's happening. That's all covered later on, or as we go through the debug sections of this course. Right, so we've created our first app, we've run it. I'll just hit stop. And we're ready to proceed with a little bit of coding. But first of all, in the next lecture, we're actually going to look at all of this structure on the left-hand side. What are all these files and what do they do? Welcome to this lecture on looking at the actual iOS-specific project layout that we have. The first file is one I've touched on already, and this is the appdelegate.cs, which is open in this window. As I said before, this is the area that the iOS operating system uses to communicate to your app. So if there are special events like audio changing hands, it will most likely pass through here. Now, I've pulled up Xcode in a separate window. I've created a blank project and I've opened appdelegate.swift. So this is a project written in the Swift programming language instead of C#. You'll notice immediately we have the same patterns. We have a class called appDelegate, a UI responder, and a UI appDelegate. Inside of Xamarin, we have a class called appDelegate, which inherits from UI application delegate. So switching between C# and Swift isn't too much of a stretch. And as a developer, I started with C#. I actually started with web things, but my first real, in inverted commas, language was C#, and I learnt how to program apps using C#. I then moved on to Java for Android and Swift 2 for iOS because I wanted to learn more in depth. And I can tell you that if you stick with C#, it's a great start, and later on you'll start to recognize the patterns which will allow you to move over to Swift and Java. Okay, we have our app delegate. The next file in our list is entitlements.plist. If you want to use various iOS services like iCloud and Apple Pay, you have to ask for them inside of this file. They're usually fairly complicated permissions that you'd ask for in here, so your first apps won't use things like HomeKit and HealthKit. Then we have our info.plist, and this is a container for all of the variables that iOS wants to know about when our app is installed. It also wants to know what our main interface is, what orientations we will support, so do we want our user to rotate the screen or not, and various other properties in here. It also allows us to set our launch images either from a catalog or from a special launch screen. We have various other things there. We can ask for background modes like audio and AirPlay. If you're making a streaming app, you would definitely want the audio section. Right, then we have something that is unique to C# and .NET in general. This is the main.cs. And if you're a .NET developer, you'll recognize this static method called main as the entry point to your application. In fact, that's what's written in the comment just above it. So your application will jump in here, initialize insights if you want to use it. We're not going to cover that. And then fire off the main UI application app delegate. So if we look at the Swift project, the application actually starts on app delegate automatically. There is no main file. So that's unique to our Xamarin platform. We're generally not going to modify that main method. So I'll just close some of these. Then we're on to main.storyboard. Now if I double click this, it's going to open it and it's going to give us a designer. And this is something I'm going to cover later on in this course. This designer allows us to separate out the graphical elements and the programmatic elements of our app. You get the same thing inside of Xcode and Swift. So I'll hit main.storyboard, and inside here we have a view controller. So if I switch back to Xamarin, we have the same idea. We have a view controller. We have this arrow on the left, which is the same as Xcode, and that is the main entry point of the application. So this arrow tells us what screen are we going to present to the user first. We have a packages.config. We're not going to worry about this right now. And finally, we have a viewcontroller.cs and a code file that is in a tree line with that. So open up viewcontroller.cs and have a look in here. We have a class, we have a bunch of methods, primary of which is viewDidLoad. So this viewController package loads when our app first fires up. This main.storyboard viewController is opened, and the code behind it, which is linked to that storyboard, is then executed. Inside of viewDidLoad, you are going to have code to make app. Generally, this is your starting point. Okay, just one or two more things to cover, and that is these folders here. We have references, and if I click that down, you'll notice Xamarin.ios features prominently. Obviously, we need that package because we're going from C# to native iOS. And this, if we right-click it, we can edit them, and we can add more references to various classes. We have components. This is the Xamarin Components Store, and if we double click it and hit Get More Components, we can find a whole bunch of things that we can include in our apps, and they have a handy icon on the right that tells us which platforms they are good for. So Azure Mobile Client SDK is good for every mobile platform. We have packages. And packages we can install from NuGet. If you don't know what NuGet is, it's just a repository manager. We have various things in there. For example, if I looked up Google Ads, we could get a package for Google Ads. We could get a package for Play Services, etc. A common question I get is, what's the difference between components and packages? And the answer is none, really. Components is a repository that Xamarin controls, so they can actually charge for some of the components, and some of them are actually worth it. Packages, no one controls that. It's on NuGet, so anyone can upload to it. Generally, you'll try to start with components. If they don't work, you will revert back to packages, but they're one and the same thing. Right, the last folder we have is resources. We have one called images.xcassettes. This is generally going to hold your images, but it doesn't necessarily have to hold your images, so you can put them anywhere you like. We have some sets of app icons. This holds the app icons for us, and we'll cover that later on in the course. And we have a zip file for the launch screen. And this was the screen that was shown to us when we first ran our app on the simulator. If you double click it, we can open the designer and we can change things around if we wish by clicking on them. Okay, that is the iOS project structure in a nutshell. And it is very similar to the one in Xcode, with the exception of a few files and a few folders. So once you know how to do this in Xamarin, you could easily transfer over to Xcode if you wished to learn Swift too. It's very important in iOS to know what order things happen in when a view controller is loaded. So this little test section, I'm going to set you a task, and that is to open our viewcontroller.cs. If you recall, this is the first file that gets loaded in our app in a graphical sense. And inside view.did_load, I'm going to type console.writeLine and view.did_load. What this does is write a message back to our application output that our view did load. So if I hit run, we build and we upload it to our simulator. It's going to run, but if we look in our application output and I scroll down, we have a view did load. So it's still loading things. There we go. From my first app. So after the view loaded, we had some errors for other things. I'm not quite sure what they are, but you can always explore that if you wish. I wouldn't worry about those errors for now. We have a view did load. Inside, I'll just stop this running. You should do the same. Inside of a view controller class, which inherits from UI view controller, there are a couple of default methods. So one of them is view, we have to type override first, view will appear. We have a public override view will disappear. Now, when do these events fire off? Well, they fire off depending on what our app is doing. So the first time it loads, will get a view did load once. If the view disappears, this will get fired off. So for example, if I clicked the home button, I believe, or I opened a new screen on top of the current one, view will disappear, fires. And then if a view appears again, this will fire off. So your homework is to use that console.writeLine view did load and change it slightly to view will appear, pop it into the view will appear method, do the same thing for view will disappear, then also open up app delegate and put it inside finished launching before return true is called. Then I want you to run the app, have a look at your application output and see what order things are fired in. And this is intensely important when it comes to app development, so please do not skip this, because you need to get into your head the various processes that iOS runs through when your app fires up. In the next lecture, I will cover the solution to this. Okay, let's cover the solution to your task. And your task was to see what order things load in View Controller and App Delegate. So I'm going to pop in my code, console.writeLine view will appear. I totally can't spell today. And we'll have one for view will disappear. And let's pop one into the app delegate. Let's have delegate loaded. And you'll notice we have red under console. And that's because if we right click it, we need to resolve it by using system. And this is going to paste in using system to grab the .NET system class for us. Now I'm going to hit play and we're going to observe the order that these write lines are going to appear in. So let it load. Open up the application output. I'll make it nice and big so we can see. There we go. First we had the delegate. Then we had view did load. Then the view appeared. So did load will fire first, then it will appear. Then we haven't had disappear yet because we still have the view on our screen. If I was to open up another screen on top of this one, then view will disappear would load. Likewise, there are many other methods inside of here that all have a hierarchy. So I'm going to override view did disappear. And you can imagine that when you load something on top of your screen, view will disappear fires, and then view did disappear fires. Now, why are all of these methods so important, and why are there so many of them? Well, it's simple, really. When your user navigates away from a screen, you might want to save some data that they've input from that screen. Because mobile devices are limited on memory, and if your screen isn't currently showing, it might get disposed of, which means that your user's data would be lost unless you put it somewhere. For simple apps, this isn't really a problem, but as you get more complicated, you are going to use these various methods quite a lot, especially if your user is creating with your app. The last thing you ever want to do is to have a user lose some data, because they will immediately uninstall your app. It is not a good user experience. Imagine if all your calendar entries were deleted just because you went onto a new screen. That would not be a good experience. Okay, that sums up our very first Xamarin app. You've learnt all of the structure behind it. You've done a little bit of coding, especially how to write over to your application output inside of Xamarin Studio. Well done for reaching the end of this section. In this section, you've learnt how to create your very first iOS project in Xamarin. You've also learnt what all of the different files and folders are for and what order they get called in when your app is started. As a bonus, I also compared Xamarin file layout to Xcode and Swift 2, which is the traditional way of making iOS apps. You perhaps noticed that they weren't actually that much different, but because we're using .NET, we have some things like main methods that we have to adhere to, but overall, they were very similar in structure. Then I set you a little task, which was to do your console.println over to the application window, and in that task, you actually discovered the order that various methods inside of your view controller and your app delegate get called.